All right, we're going to work on this page now, 524, correct?
Yes.
Why don't you all have your books open? Because we're going over it. As I told you, there's going to be a test on Friday over this type of material. A test on Friday over this type of material. The example, this question says, the pattern below follows the rule x plus 3. What kind of pattern is x plus 3?
It's algebraic.
No, it's what kind of pattern? Yes. Is it an additive pattern or a multiplicative? Additive. Anytime you're adding, it's an additive pattern. Where y is the number of squares and x is the figure number. So if I look here, what figure number is this? How 4? What figure number is this? 1. And how many squares does it have? 4. Y is the number of squares. What figure number is this?
2.
And how many squares does it have?
5.
5. What figure number is this?
3.
3. And how many squares?
6.
Okay, x plus 3. X plus 3. 1 plus 3 gave us 4, ladies. 2 plus 3 gave us 5. 3 plus 3 gave us 6. If you'd have read this, you don't even have to draw the other pictures. Our x is 4 because it wants us to take it out to 5, to figure 5. Then we're going to put it in this coordinate grid. Okay? 4 plus 3 is 7. 5 plus 3 is 8. This was not hard. Some of you didn't read this. You just said, I don't get it. If you read this, it told you exactly what to do. Take your input, or take your x, and add 3, which gave you your y. So, the pattern in this for the number of squares is what, Salon? 4, 5, 6, 7, 8. 4, 5, 6, 7, 8. So then we write the ordered pairs using the figure number and the number of squares. It gave us 1, 4. It gave us 2, 5. Addison, what's the next ordered pair here? 3, 6. What is the... Oh, sorry, they're doing it. 3, 6. The next ordered pair, Nevaeh. Good, 4, 7. The next ordered pair, Ethan. 5, 8. Okay, if you read it, you'd see that you're adding 3, and you'd be able to figure it out very quickly, very easily. Now we're going to take and graph these points on this ordered pair. Plot the ordered pair and the ordered pairs in the graph. So Evan, if you'll slide it up. Okay, so we're going to plot the ordered pair in these graphs. Again, the x is what? The first number stands for what?
Output.
No? First number is the figure number. The y is the number of blocks. Okay, so figure 1 had how many blocks, Jocelyn? 4 blocks. Figure 2 had how many blocks, Joseph? Not about, exactly. 5 blocks. And that's halfway between 4 and 6. Some of you yesterday when we were doing this, you're like, there's no line for 5. You just, it's easy to do. Helen, figure 3. 6. Figure 4. Oh, Ivan. Okay. 4, not 4, 8.
4, 7.
4, 7. Figure 5 is what? Betsy. 5, 8. Did we have to take it out any further? No. Okay, if they're giving you an input-output table and you have a rule, like we had here, x plus 3, or even if it was x times 3 gives you y, you're always going to come out with a straight line. Okay, if you're taking it from a function table or an input-output table, you're going to come up with a straight line if it has the same rule. If you're doing the same thing to the x to get the y every single time, you're going to end up with a straight line like this. Okay? It should, Joseph, does yours look like this?
Yes.
No, not even close. Not even close. It should look like this. We're just putting the dots on there. We're not putting any lines or anything else on there. Just the dots. Okay, coordinate graphing, we just do the dots unless it says to connect them. Like on those pictures of, Mockingjay. All right, slide it up. All right, use the given rule to complete the pattern. Display the pattern in the coordinate grid. What kind of pattern is this one? Tell me the pattern.
By 5. Addition?
Multiplicative. It says multiply the number of nickels by 5. Because there are 5 pennies in each nickel. Number of pennies that equal the value. 3 times 5 is 15. 4 times 5 is 20. You need to remember these names. This is a multiplicative.
Multiplicative.
And I'm not sure that's spelled correctly, but multiplicative. What does the X stand for? Pennies or nickels? Nickels.
Full.
The Y stands for pennies. Okay, so tell me the first ordered pair, Evan.
1 and 5.
1 and 5. The next ordered pair, Betsy. 2, 10. Bethany. Joseph. 4, 20. You gotta say both of them. 4, 20. And again, we're following the same pattern for each input, so it's going to form a straight line. So if you had a pattern on here, unless you're answering the question, if you had a pattern on here that you had to follow, multiplicative or additive, it's going to follow a straight line. Okay? This one, if we read the problem, which we're not doing, add 5 to the input. So that makes this an additive property. Additive. I don't know how it's spelled, but something like that. So, as a class, the input's 1, the output is?
6.
The input's 2, the output is?
7.
The input's 3, the output is?
8.
The input's
9.
4. Okay, then we have to display it on the graph. So, the first one is going to be, what's my ordered pair, class?
1,
1,
6.
6. Second ordered pair.
2, 7.
Third order pair.
3, 8.
Next order pair.
4, 9.
And again, straight line. Forms a straight line, so we're golden. So if you had a problem, and it said you had a pattern on your input-output table that you add 5 every time, you're going to come up with a straight line. They would be all lined up. They would be all lined up. Questions on 1 and 2? Nope. All right. Slide it up, because I don't have parent permission. All right. So this one, they're giving you the rule. The rule for the pattern is add 4 to the input. So if I had an input-output table, use the rule to write the ordered pairs that represent the pattern. So what would I do to get from input to output? What does it say to do? I would add 4 to the input. It's an additive pattern. You would add 4 to the input. So now it says, we'll make 4. We'll make 4 inputs on here. So pick any number. Pick a number. 6. And what would the output be?
9.
Add 4. It says add 4. It's an additive pattern.
Oh,
10. Isaac, pick a number.
10. 7.
My output would be?
11.
Pick a number. Who have I not called on today? Nevaeh, pick a number. 8. What's the output? 12. I'm going to pick a number. 36. What's my output? 40. It doesn't matter what the input says. The input could say 1,278,412. The output, you would just add 4 to it. So even though this jumps all the way to 36, still the output is you only add 4. Okay, so we used the rule. We wrote some ordered pairs. So that would be 6, 10. That would be 7, 11. That would be 8, 12. And that would be 36, 40. And your paper didn't have to have this exact input-output table, but if you read the directions, you had to have an input-output table to answer this question. But you could pick any input, add 4 to it to get your output. Okay, it doesn't say graph these, so we're good. Don't slide it up yet. So that's how you should have answered 3. Number 4, write 5 ordered pairs that represent the pattern. Multiply the input by 3. And then we graph it in the coordinate grid. So 5 ordered pairs, input multiplied by 3. So my input, my output, and it's multiplied by 3. So it's going to be x times 3. Or 3x, you might see it written. So let's pick numbers. Let's pick numbers under 10. Let's go 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, I'm going to pick the numbers. 1. What's my output? 3. 2. What's my output?
6.
3. What's my output?
9.
4. What's my output?
12.
We have to write how many ordered pairs? 5. 5. What's my output? 15. Okay, so I'm going to count these by, let's count them by 2s. 2, 4, 6, 8, 10, 12, 14, 16. We'll do the same here. 2. Why are you walking in front?
Sorry.
No, you're not. 4, 6, 8, 10, 12. And then this one will be 15. Then this one will be 15. All right, so my first ordered pair is what, Ashley? What's my first ordered pair? Okay, 1, 3. So that's going to be right about here. Again, it doesn't have to be on the lines because this is over 2. I only want 1, so I just go halfway between it. Halfway between 2 and 4 is 3. My next ordered pair, Bethany. 2, 6, a 2 over, 6 up. My next ordered pair, Ethan. 3, 9. Again, 3's in between 2 and 4. We go up to 9. which is in between 8 and 10. My next ordered pair, Lainey. We just did 3, 9. 4, 12. So that's going to be 4 over, 12 up. My last ordered pair, Joseph. My last ordered pair.
30.
No, what's it say?
Oh, 5 times 2
Okay, 5, 15. So it goes up to 5 and 12, 14. So it would be right about here. Notice we have another straight line. Another straight line. So very easily. All right, so one more or 2 more. Slide it up for me. That's B, our friend. All right, use the coordinate plane for 5 through 7. Emily has a road map with a key that shows an inch on the map equals 5 miles of actual distance. So 1 inch on the map is 5 miles actual distance. Use the table and the coordinate grid to show the pattern. So if 1 inch equals 5 miles, 2 inches equals 10 miles, 3 inches equals 4 inches equals 5 inches.
25.
Okay, so we're out of time for this, but go through, graph it, go through the other ones. If you slow yourself down, read what it says, then I'm not going to get the, I don't understand what to do. Okay, if you're watching at home, pause between questions, go through this, because you're going to see questions like this on the quiz on Friday. Love y'all. Peace out.